These are the solutions for our topics 2 and 3 test review, part 3. So number 1 here says which triangle was constructed congruent to the given triangle. So the idea here is that we have this given triangle at the top and it says given, and we're asked, and they're going to copy the triangle. So the answer is figure 2. The reason is because in here, in the given triangle, you can see that we're already placing some markings to copy parts of this triangle. So it looks like we're copying this angle here, and we're copying this angle here. Okay, and although figure 1 looks like it's doing the same thing, it's missing a couple of the marks. It doesn't have this mark here that you would need, and this mark here that you would need. And then these two triangles down here, they're copying the same angles, this one and this one. In this case, figure 4 is only copying one, but they're copying the wrong line segments. Okay, so this one's triangle 2. Next question, number 2. A student used a compass and a straight edge to bisect angle ABC in this figure. Which statement best describes point S? So the answer to this one is D, because QS is this distance here, and PS is this distance here. And if you're going to bisect an angle, after you complete this first step, drawing this circle whose center is at the vertex B, the next step is to put the compass at Q and then draw this circle right here, and then put the compass at P for the next step and draw this circle right here. Okay, and then where that intersection occurs, you plot a point, and then you can go ahead and connect the dots here, and that'll let you draw the angle bisector. Now, I just want to go over one of these because, at least in the picture, they look the same. So the answer is D, but let's look at, let's see, PS, BQ. Yeah, let's look at C. Like, why is this one not correct? So let's erase some of this stuff. Okay, so PS is this line segment, and BQ is this line segment. So the way we do it on IXL, that's actually correct. These two would actually come out the same. Because the way we do it on IXL is whatever size circle we put centered at the vertex, we just always use the same size circle when we come over here to this point. And to this point P. We just use the same size circle. So, of course, this length here is going to be the same as this one. But it doesn't have to be that way. You don't have to use the same size circle at the beginning, at the first point here, at the vertex B, and then the same size circle at Q and at P. You don't have to do that. You could use smaller circles at P and Q or bigger circles at P and Q, as long as they're the same size. But they don't have to be the same size as the original one that you put at B. Okay, so let's go on to the next one. This question is kind of anticlimactic. On a lot of these questions, you're kind of figuring out something interesting or important, but on this one, that doesn't really happen. So this question says, what is the first step in constructing congruent angles? So on IXL, they always gave you the ray that you want to copy the angle to. So let's see, this top one here is the given angle. And then this ray down here, DF, is the ray that you want to copy the angle to. Okay, so on IXL, they just give you DF. And then you got to you got to copy this distance from A out to here. Then you got to copy the second distance from this point out to this point here. And then you get this point of intersection. Then you need to copy that down here. So you got this length out to here with this semicircle. And then you put this point down, the compass down, and then you get this. And then this point of intersection right here that I'm coloring in black, that lets you draw the ray finally at the end. But IXL gives you DF. In this case, none of these options have much to do with copying an angle, B, C, or D. So the answer is A, it's just draw DF. So yeah, I guess if you wanted to copy angle BAC, if you wanted to copy this angle BAC, the first thing you would have to do is draw a new ray, DF, to actually start copying the angle to. So that's kind of a boring question. Okay. So this one's number 4. It says Melanie wants to construct the perpendicular bisector of line segment AB using a compass and a straight edge. Okay. So the answer to this one is B. So what you would do is you would center a circle at A so that its radius goes out further than halfway. So this is a discussion we had in class. We had like this line segment on a previous exit ticket. It was like TW, and then it had different options. Like A was 1/5 of TW, and then option B was like 2/5 or something like that. And then finally the answer was that it was 3/4 TW. And the significance of 3/4 was just that it was bigger than halfway. Okay, so we can't really tell how far this goes, but we can tell it's further than halfway. Option A over here, that's the case where it goes exactly halfway, and the problem with that is that the two circles meet at this one spot, and you don't get the situation that you do in option B, where you get these 2 points of intersection and you can connect the dots, connect the points to make the perpendicular bisector. You don't get that in option A. Okay, and then option C is not even close. We don't really get anything new out of that. And then the problem with option D is that one of the circles is smaller than the other one. And therefore, this point right here is not actually at the midpoint of the line segment AB. Okay, so the answer for this one is B. Okay, next one. I like this question. The radius of circle O is R. Okay, so let's label that. The radius goes from the center out to the edge, P, so this is R. A circle with the same radius is drawn around P. Intersects circle O at point R. Okay, so this R is not to be confused with little r for the radius of the circle. This is a point. What is the measured angle ROP? Okay, so let's try to get this second circle drawn. So it says a circle with the same radius, but drawn around P. Okay, so same radius. Okay, looking pretty good. Okay, so here we actually get 2 points of intersection. See, up here it says P intersects circle O at point R. So that could either be up here or down here. I think the beginning of my circle was probably better, so we'll use the top one. So we'll call this point R. And it's asking, what is the measure of angle ROP? So ROP is this angle right here. Okay, and at first it seems pretty random and impossible to figure out, but actually this is how you construct an equilateral triangle. So if you connected R and P, this is actually an equilateral triangle. So this side is the same as this side and it's the same as this side, as well as the angles. All three angles in there are the same. And since the triangle has to add up to 180 degrees, then if we do 180 divided by 3, that gives us 60. Then the measure of all three of its angles are 60 degrees. And in particular, the one that we're interested in, this one, centered at O, or whose vertex is at O, it's also 60 degrees. So the answer to this one is 60. Okay, done. Next question. Number 2. It says Carol is constructing an equilateral triangle with P and R being two of the vertices. That means that one of its sides is that line segment, PR. She's going to use a compass to draw circles around P and R. What should be the radius of the circles? Okay, so we've done this construction on IXL a few times. It has to be D. It has to be the same length. So take a circle centered at P with radius PR. Okay, and then a circle centered at R this time with same radius PR. Okay, and then if you connect that point of intersection at the top with the two previous ones, we get an equilateral triangle. So, and the radius was just D. Okay, next question. It says Daya is drawing a square inscribed in a circle using a compass and a straight edge. Her first two steps are shown. So step 1 was to draw a circle. And step 2 was to draw a diameter of the circle. And the way you would draw that is you would just pick a point on the circle, call it P, and then you would connect that with the origin of the circle, or the center of the circle. And then that would let you draw this line. Okay. So it says which is the best step for Daya to do next for constructing the square inscribed in the circle. Okay, well actually these 2 points on the edge of the circle that intersect this line, those are two of the vertices of the square. The other two vertices have to end up somewhere up here and the other one down here. And then if you connect these, you can see they look like the 4 of them make a square. So the question is, how do we get these two? And if you look carefully, it kind of looks like those are on the perpendicular bisector of PR, where R is this one on the left. Okay, so we have to figure out in which one of these diagrams does it look like they're constructing a perpendicular bisector to the original given line, PR. Okay, and the answer for that is D right here. If you draw the perpendicular bisector, so these are the two original points that I pointed out. And then if you draw the perpendicular bisector going through those 2 points of intersection, then that gives us this point on the circle and this point on the circle. And then that'll allow us to draw the square. So the answer is D. Okay, next one, number 5. Carolina wanted to construct a polygon inscribed in a circle by paper folding. She completed the following steps. Start with a paper circle, fold it in half, make a crease. Okay, so let's try to draw out these steps. So we have a paper circle, and then it says fold it in half. Okay, so we fold it in half here, and we should end up with something like this, a semicircle. Take the half circle and fold it in thirds. Okay, so you're gonna fold these in thirds. So that means you're gonna fold it like this and like this. So that's 3 equal pieces. Open the paper up. Mark the points of mark the intersection points of the creases with the circle. So after you open this thing up, let's do that, let's show that. So we'll go back to being a circle, and we're gonna have this crease marks like that, and these like that. And don't forget about this fold line in the middle when we folded the paper in half, this one. We're also gonna have that one. Okay. And then when we go ahead and mark the points of intersection between the creases and the edge of the circle, we got this. Then it says, connect adjacent intersection points on the circle with segments. So we're going to connect these line segments. And we get a 6-sided figure, which is a regular hexagon. Right there. Okay. So that's it for part 3.